All right, first up here, number one. So for this one, we want to just determine the end behavior. So for this, I see it's degree 3 positive. So that's, I always think of a slope here for odd degrees. So it's going to be going down to the left and up to the right. So I would just write like that, down to the left and then up to the right. And so then I would translate that into the infinities by saying y goes to negative infinity as x goes to negative infinity, and then y goes to positive infinity as x goes to positive infinity. So now I got to look for that. And so I see on option A, both of the y's are negative, so I don't want that. Option B, this y is going to 0, so that's no good. This option C, one of the y's is going to 0, that's no good. D looks like it's reverse of what I want, and then E looks like it is what I want, so it's going to be option E. All right, next up, number 2, we're looking for the possible rational zeros. And so for that, we do this process. The rational zeros theorem says P over Q, where P is all the factors of that last number, 34. So that would be 1, 2, let's see, it doesn't divide by 3, nor 4. I think that's pretty much it until 17 and 34. So that's it for that. And then Q is the all the factors of the number out front, so it's going to be 1 and 2. So we do have to actually kind of divide these out. So we'll do 1 over 1, which is 1, 2 over 1, which is 2, and then obviously dividing by 1 is going to be pretty easy for us here. So now, though, I need to also divide everything by 2, so I'll do that as well. So 1 over 2 is 1/2. And then 2 over 2 I actually already have as 1. So I'm not going to write that again, but 17 over 2 I don't have yet. And then 34 over 2 I actually already have as 17. So I need to find all of these numbers. It doesn't have to necessarily be in that order. Looks like this one's missing some. This one has that 1 over 20. I don't like that there. 1 over 34, that's not correct. D is looking good. Yep, it is D. It has all of them there. All right, lastly, on this page, number 3, so this one's end behavior again. So kind of like number 1, except with a different degree here, a degree of 4. So I'll let you guys try that on your own. All right, next up here, we got number 4. So on this one, it says find all the zeros. Normally, I would do P over Q on this one, but since it's kind of a multiple choice, or in this case, is select all that apply, I'm just going to try out the ones that are given to me. So I'll try out just 1/2 first. I'll kind of, I don't want to do these ones. A and F look like they come from quadratic formula, so I'm not going to try those out in the synthetic division. So I'll just try out option B. So I'll try out 1/2 and see if it works. I know that some of these probably got to be right, so I'm just going to start testing these out. So I got 2, and then that's 1, 16, and then that's 8, so then that's 25. And that's 25 over 2, which I kind of already know is not going to be correct because that's turning into fractions. So I'm going to say B is incorrect. So now I'm going to try C, which is just 1. So I get 2, 2, 17, 17, 34, 34, 37. And looks like it's definitely going to be too big here. So 1 is incorrect as well. So let's go ahead and try negative 1/2. So we get 2, negative 1, 14, negative 7, 10, negative 5, negative 2, and then positive 1 and 0. So that one does work out. And so I could write this then as x. So first of all, I know that that's correct, but I can also keep going with this. So write that as x plus 1/2 times 2x to the third plus 14x squared plus 10x minus 2. So now I actually see I can GCF here. So I'm going to take a 2 outside of that and just call this x to the third plus 7x squared plus 5x minus 1. And I'm just going to continue on with my, and actually I'll send that back into here eventually to call that 2x plus 1. But I'm going to keep going here on my, my leftovers. So I'm going to try out the last one I haven't tried here, which is negative 1. So I got 1, negative 1, 6, negative 6, negative 1, positive 1, and that gives me 0. So that is good. So then I have 2x plus 1 times x plus 1 times x squared plus 6x minus 1. And that I'm getting that from my leftovers there. And so I see that the result here is not factorable. Oh, but actually that does tell me that E is correct. But I see the result is not factorable, so I'm just going to have to use quadratic formula on that. And it looks like that will probably either give me option A or F. So I'll let you guys try that out and see which one it gives you. All right, next up, number 5. So for this one, I want to find all the factors here. So I actually want to, I noticed that this is will work as grouping. So I'm going to, or at least I think so. So I'm going to just take out the 4x squared here. And I need to make sure that we get the same thing inside of both parentheses. And if I take out the -1 here, I see that we do. So that means grouping is going to work. P over Q may have worked as well, but the grouping, if it works, is a lot easier and quicker here. So we get 2x plus 1 and 2x minus 1 and then x plus 1. And so from there, I can see that A is correct. And then F is also correct, E is incorrect, and D is incorrect, and B is incorrect. All right, now C is actually a little weird here. It looks like that's not there, but actually I do notice on this this one right here, if I take out a 2 and then that turns into x plus 1/2 and kind of keep these the same, technically speaking, that is a factor then. Because I am able to create that by a GCF here. It's kind of a weird fraction with a weird factor with a fraction in it, but it is still technically a factor. All right, I'm gonna let you guys try number 6 on your own. I'll go ahead and do number 7. So I'm gonna build my polynomial here. So for this one, I'm gonna put x plus 1. For 0, I'm actually gonna put a 1 or an x out front. I'm actually gonna do this one next because I like my conjugates next to each other. And then I'll do this one as 2x minus 3. Whenever you have a fraction, you can take the denominator out to the front, and I need to do that twice because it's of multiplicity 2. So I'm going to go ahead and flip these two because they are conjugates. These two I need to do a full FOIL. So that's going to be 4x squared minus 6x is minus 12x plus 9. And then now I'm going to multiply these two together. I'll distribute the x last. You could do that earlier, but I like to do it last. All right, so then we get 4x to the 4th. Oh, that's my only third power right there. So minus 12x to the 3rd plus 5x squared plus 12x minus 9. And, oh, now I need to multiply my x in that I had out front. So that'll become 4x to the 5th minus 12x to the 4th plus 5x to the 3rd. Plus 12x squared, and then minus 9x. Now the last thing it says here is that we want a linear coefficient of 12. So right now my linear coefficient, the first power is -9. So I need to think of myself, what could I multiply by -9 to turn it into a positive 12? And so I can divide that by -9. And then I get A equals -4 over 3 if I reduce that fraction. So what that means is I need to multiply this whole equation by -4 over 3. I'm not allowed to just do terms individually. So we're going to distribute that in. I'll let you guys try that and then check your answer. All right, next up we'll do 8 and 9. I'll go ahead and do number 9 here. It's a little trickier. So I would first state the degree. So for factored form, we would add up the degrees. And so we have 6, 7, 8, 9. And it's negative. So then that's going to go up to the left and down to the right. My zeros here, I have 0 with multiplicity 4, which means it's going to bounce. That's for this out front. Anytime you have a variable GCF'd out front like that, even if it's multiplying by a number, it's always at 0. The next one here will be -5 over 2 or -2.5 with multiplicity 2, which will also be a bounce. And then at 2 with multiplicity 1, which will be a cut since it's odd. And then 4 with multiplicity 2, which will be a bounce as well. All right, so let's draw those in there. We got 0, we got -2.5. We have +2, and we have +4. Okay, so what's the only cutting one is the 2. So we're going to bounce off this one, cut through. Oh, missed it a bit there. Let's try it again. Bounce off that one, and then cut through, and then bounce off. All right, next up, number 10, we want to find all the zeros. So we're going to have to use P over Q here since we don't have any clue. We can't use grouping either because our ratios are off here. It's not the same. You could try it, but the parentheses won't come out the same. So P there then is plus or minus 1 since that's the number out back. The number in front is 5, so we need to do 1 and 5 because those are the factors. So now we'll divide these out. So I have plus or minus 1 and plus or minus 1/5. So I'll try these out. So I'll try out 1. We do have a 0 there for our linear. So we get 5, 5, 41, 41. And I'm already kind of seeing this is going to be too big. So I'm just actually going to stop right there. I know it's not going to work. So I'm going to switch over to -1 and see if that works. So we get 5, -5, 31, -31, 1, -1, -1, 1, and 0. So that one does work. But I do need to find another one here. So I'm going to go ahead and try 1/5 on my leftovers here. So then I'll bring that down as 5. And that'll be a 1. And then that'll be 32. This will be 32 over 5, which I kind of already know when it's a fraction, it's not going to work. So I'm going to take these leftovers over here, and now we'll try -1/5. I'm ignoring that 0 there. It's not really part of this. So then we'll get this as a 30, and then that'll be -6. -5 turns into 1, and then we do get that 0 at the end. So I have x plus 1 for the first one that worked. And then x plus 1/5 for the 1/5. And then on these ones, I see I can GCF a 5 here, so I'm going to go ahead and do that, giving me x squared plus 6x minus 5. And so I can send this in there if I want, and then you can factor this one, or if it doesn't factor, you can use the quadratic formula. So I'll let you guys finish that one. All right, number 13, on that one, it's very much like number 2. I already did that one, so if you need help on that one, you can check out number 2. I'll go ahead and do number 14, though. So for this one, we're going to set up our factors here. And then we'll expand it. I'm going to fold these two because they are conjugates. And we get x to the third minus 4x squared minus 9x, and then plus 36. Now in this one it says we want a y-intercept of -144. So the y-intercept is always the c value. You can think of it like x is 0. So if x is 0, it kind of zeroes out all of these terms, and we're left with that. So right now my y-intercept is not -144. So what I need to do is think about like if I need to multiply the whole equation by something that would turn that 36 into a -144. So I'm going to divide that 36 over. And 144 divided by 36, I think that's 4. 420. Yep. So A is going to be -4 here. So I need to multiply this whole equation by -4. All right, next up, number 15, they want us to factor this one completely. So I do see a GCF. I would definitely take that out first. Okay. And then this is an x box here, but it's an x box with x squared in front of each, which gives us that x to the 4th. And so it's, let's see, that would be +3 and -1. So +3 minus 1. And then I noticed that we have perfect squares here, so I can break this down further. All right, number 16 is kind of very similar to the other ones we've done here, except they want the cubic coefficient of 2, so that's the x cubed. So that's the last step. You just multiply the whole equation by something to turn it into that. I'll go and do number 17. We need to do some long division here. So I'm going to put the x squared plus 1 out here. And then in there, I'm going to do my x to the 6th plus 0x to the 5th plus 8x to the 4th plus 0x to the 3rd plus 15x squared plus 0x plus 8. So I'm going to start off with my first thing inside divided by first thing outside, and that'll be x to the 4th. So I'll go ahead and put that right there. And then we'll multiply that by the front, so then we get x to the 6th right there, and then x to the 4th right there. And then I switch the signs here, add them down, so these cancel. I'm not going to draw that one because it's still 0, so then I get 7x to the 4th plus 0x to the 3rd plus 15x squared plus 0x plus 8. So now I'm going to do my new first thing inside, divided by first thing outside. So that gives me 7x squared. So then I get 7x squared right there. And now I'm going to multiply that by the front and put that underneath. So then that becomes -7, or actually it's positive 7x to the fourth, but then I switch it to negative. And then 7x squared, which I'll also switch to negative. So now we can add down. These cancel, there's nothing there. So then I get 8x squared plus 0x plus 8. So now one more round of first thing inside divided by first thing outside. Since I know the powers are the same now, that's going to be the last piece of my answer, which is 8. I'll go ahead and multiply that by the front. So that gives me 8x squared and 8. I'll change the signs, and then I actually get no remainder. So that's it. That's my answer. All right, next up here, it's asking me for p of -6. Now, instead of actually plugging in -6, we can just use synthetic division, and then whatever we get as our remainder is our answer. So I'm just going to list these numbers out. So I get 5, -30, -5, positive 30, -5, positive 30, 61, and that would be -366. Yep, and then so I'll add those down, and that'll be -354. All right, find all rational zeros here. You could use P over Q. However, I noticed that these are in the same ratio, so I would use grouping instead. It's just easier. So then I would take out an x squared, leaving me with 4x minus 3. Take out a -1, leaving me with 4x minus 3. You do need to solve this at some point, so yeah, it's equal to 0. So I'll let you guys solve it from there, though. All right, next up here, number 22. So for this one, we are going to just graph this. So I'm going to go ahead and graph it. I know it's degree, let's see, 7 negative, so it'll be going like that. And then I have a 0 at 0, which is going to bounce. 5 is going to bounce, and then -3/2 will be our lone cutter there. So we're going to cut through at -2, and then bounce, and then bounce. So when we're doing these inequalities, we just think of this as plus and these as minus. So where is it greater than 0? So that would be -infinity to -3/2 with a bracket. However, I also need to include the other x-intercepts kind of on an island here, since they are greater than or equal to 0, specifically equal to 0. For the less than or equal to 0, it's all of these zones here, and there's really no break there because the x-intercepts are included. So I'm just going to combine all of those into a supergroup, so I'll go -3/2 to infinity. All right, number 23, you're going to use synthetic division, but they're telling you that -3 is a 0, so you're going to start off with that one, and then get down to the quadratic, and then you can either factor or use quadratic formula. Number 24, we always want to get these one side to 0 by adding or subtracting, so I'm going to go ahead and subtract that over. And now I'm going to graph this to help me out. So I know it's degree 4 positive, so I'll have up and up there. And I'm going to go ahead and factor it here by GCFing an x squared, giving me x squared minus 4. And then go x minus 2, x plus 2. So it looks like I got a bouncer at 0 and then cutters at -2 and 2. So this will look like this. All right, so where is this greater than 0? That would be over here and over here. So that would be -infinity to -2. And then from 2 to infinity. I'm not going to include 0 here because technically these are all open dots. So the x-intercepts are not part of my answer. All right, next up, we're going to write this polynomial. So I see our x-intercepts are there and there. I got x plus 2 then, since it's -2. But since it's a bouncer, I'm going to put it twice. I have x minus 1 right there. So I'll FOIL this out as x squared plus 4x plus 4 times x minus 1. And then we'll go ahead and multiply these together. I like to use the box for that. So x minus 1 will give me x to the third, 4x squared, 4x, -x squared, -4x, and then -4. So then I have x to the third plus 3x squared. These cancel out, and I get -4. I do notice that the y-intercept is here at -4, so I think that that's just a good equation right there.